Alright, let's talk about how to figure out the math if you're going to put a pipe through a plate at an angle. And mainly what we're talking about here is what is the shape of the hole of when the pipe goes through the plate. Now, if it's at a 90, then the hole will be a circle. But because we're adding to the mix an angle, then we're not going to get a circle. We're going to get like an elongated circle, and that type of shape is called an ellipse. And basically we need to figure out a little bit of information to create, or to have an idea of what the dimensions of that ellipse will be. Excuse me. So in this example, we are going to work with a 4-inch Schedule 40 pipe, and we're going to have the pipe go through a plate at 60 degrees. What we want to know is the outside diameter of that pipe. And so it's a good idea, if you have your pipe schedule on hand, we can look at it. And I'm going to go ahead and use mine so we can look at this if you don't have one on hand. Now, the 4-inch is the pipe size, okay? That is not the outside diameter. So when you're looking at your pipe schedule, you need to go down and find the size 4, and then look across to the next column, which is OD in inches. OD stands for outside diameter. And so the 4-inch pipe has an outside diameter of 4.5 inches. Now this 4 is it's an approximate or a nominal dimension of the inside diameter. But for the purpose of this exercise, we want to know the outside diameter. So in this case, the outside diameter is 4.5 inches. Now if you skip this part, looking in the pipe schedule and finding the OD, and you use 4 instead of 4.5, your ellipse is not going to be big enough. So use the right numbers. Alright, we're going to create a right triangle to figure out the width and length of our ellipse. Now the width happens to be the diameter, the outside diameter. So I'm going to go ahead and create a right triangle. Now I know this is 60, and I'm going to go ahead and make a triangle. Let me just do that real quick. Let's see. Okay, and I'm going to create a line here. So this triangle is going to have a line that's perpendicular to the opposite wall. Okay, so here's my 90 degree right here. We know this is the outside diameter, so this is going to be 4.5 or 4.5 inches. This is going to be the width of our ellipse. Now we want to figure out the length of the ellipse, and that's going to be the hypotenuse of this triangle here. Okay. Now we know that this is the adjacent, if we use this angle here, this is going to be the adjacent side. This will be our hypotenuse. Now if we just created a 90 here, this is 60, 90, that's going to be 150, and we know that this full angle will be 180 because that's a straight angle, so this will be 30 degrees. So we have a 30-degree angle, the adjacent is 4.5, and we want to know the hypotenuse. And so if I write my formulas, SOHCAHTOA, okay, I'm going to pick cosine. cosine 30 equals adjacent, or 4.5, over hypotenuse. Now I guess you could use the 30, 60, 90 property. This adjacent side, of course, would be the square root of 3 side, and you would have to divide 4.5 by the square root of 3, and then that would give you this short side, and then of course you would double it to get the hypotenuse. But I think you know, a simpler way to go about it is just use cosine. You can certainly do both and compare. You should come up with the same answer. So we're going to divide 4.5 divided by cosine 30, and we're going to get 5.196. Again, I'm going to round to the third decimal place, and let's go ahead and convert that to the nearest 16th. So minus 5 times 16, and we get 3/16. So 5 and 3/16. So that's the dimension that's going to go here. That's the length of our ellipse. So 5 and 3/16. Okay, not done yet. Although we've done a lot of the math. Now you're going to need a piece of paper, not a big one, something like this, and we're going to make some lines on it. And I'll show you in a minute. It will all make sense when we start working on it. But the first line is going to be called the marking line, and we're going to be marking lines based on this point. And I like to make the marking line close to the corner, but I don't like to use the corner because the corner gets beat up after a little bit. So I'm just going to make a perpendicular line to the edge, and I'm going to call that the marking line. I'll go like this. Marking line. Or marking point. Let's do that. Marking point. Because we're really just going to be making points. Now we're going to take half of our adjacent side. So half of 4.5 is going to be 2 1/4. So from this line, I'm going to make another line at 2 1/4. And I'm going to call this X. And I'll talk about X in just a minute. Well, you know, if you want to put, you know, 2 1/4 is going to be half the tube diameter, or half the outside diameter. Put half OD for outside diameter. That might make more sense. Okay, now we're going to take half of the hypotenuse. So half of 5 and 3/16 is going to be 2 and 19/32. Now, it gets tricky when you get into 30 seconds. We could go ahead and, you know, 19/32 is really close to 20/32, which reduces to 5/8. We just know it's, you know, a 30-second shy of 5/8. So let's go ahead and make 2 and 5/8. Or if you want to go to 30 seconds, that's fine. So that's 2, half, 5/8 right there. So we're going to make another line that's perpendicular to the edge. And we're going to call this Y. And this is going to be half of the hypotenuse. That's what it is. And that's actually going to be half the length of our ellipse. Okay, so we've got 3 lines, and we're going to use this piece of paper to make points on another piece of paper that I'm going to show you, a graph basically. And we've got X and Y. Alright, now on another piece of paper, you can see I have an XY graph here. okay, coordinate graph. The x-axis is the horizontal line. The y-axis is the vertical line, okay? And in the middle, they meet. All right, so the reason I'm using x and y is because the x line is always going to be on the x-axis. So when I start, I'm going to start by putting the y is going to meet at the center, or at the point where the two lines meet, okay? And I'm going to go ahead and mark a point at this place, at this position, okay? I'm going to go ahead and zoom in so you can see. What we're going to do is we're going to make points on all four quadrants, but we have to follow this rule. The y always has to be either on this going up or going down on the y-axis, and the x always has to stay on this x-axis. So I'm going to show you, and you'll kind of get the idea after the first quadrant, but let me show you. So we're just going to move it a little, and you don't want to make really big moves because you're going to be sketching an outline here. So notice I've got the x is on the x-axis, the y is on the y-axis, but I've moved it away enough so I can make another point. Okay, now I'm going to do it again. I'm going to bring it up a little. Okay, make another point. Do some more. And you'll see, oops, I lost my way here. It's easy to get back on track though. You'll see that it's going to make an elongated circle, or it's called an ellipse. So I'm going to do 2 quadrants worth of dots, and then we can measure the length, and it should match up with our desired amount. And of course, if you think you've got this, you can let me just tell you one thing. What you're going to do for your homework is, after you sketch all the, connect all the points and create an outline, you're going to cut it out. And of course, I would recommend checking your dimensions to make sure you did it correctly. And then if it looks good, then go ahead and cut it out. You're going to put your name on the cutout. So you're going to cut out this ellipse, and you're going to turn the ellipse in with your name on it. And I'll just measure. I'll measure the width and the length, and I'll have a template and match it to my template. And if it's within a 1/16 of an inch, you're good to go. Anyway, I'm almost done with this half of the ellipse. It's kind of a fun little exercise, and there really wasn't a lot of math to it, which is kind of nice after a long quarter of some pretty intense math. Okay, so here I've done half, and you can kind of see it's not quite a circle. It's a little elongated on the ends here. I'm going to go ahead and measure. Now we should get 5 3/16 from point to point, and looks like I'm a little shy of looks like 5 1/4. But, well, depending on where I put the mark, it's within a 1/16, and I'm using a felt pen. Of course, I'd recommend not using a felt pen. That's going to give you a wider points. But for the purpose of the video, it's hard to see pencil when I make videos, so I always use a felt pen. Anyway, that's pretty close. Now, this would be half of the 4 1/2, so we should get 2 1/4, and it looks like I'm getting 2 1/4 right on the money. So that looks good. I would just continue on marking it And so if I were to just pick up here, I'm going to start here, and then I'm going to make that y go down, and then continue on. Anyway, that is really all that you need to know. If you have questions, let me know.